Okay, so I have these definitions written down. If you want to pause and write them down yourself, you can do that. So for similar triangles, our review is saying that similar triangles have the same shape but are not necessarily the same size. And for scale factor, that's the ratio of the lengths of the corresponding sides of two similar polygons. So for similar triangles, we have three different ways to prove their similarity. We can use angle-angle similarity. Remember how when we had congruency, we had angle-side angle or angle-angle side. For similar triangles, it doesn't matter about this where the side is that we know, as long as we have angle-angle similarity. If we have two angles, we know the two triangles are similar. We also have two other methods of similarity. We have side-side-side similarity, where we know the ratios of all the sides are equal. So in this case, JK over MP is equal to KL over PQ and is equal to LJ over QM. So if those are all equal, all those proportions are equal, then the two triangles are congruent. And our final one we have here is side angle side similarity, where we have side RS over XY is equal to side ST divided by side YZ. And we have their angle in between congruent, then we could say triangle RST is similar to triangle XYZ. So in this first example right here, we are asking ABC is similar to what triangle? So we said ABC. So since BC is bigger than AC, we're going to want to go across the blank and then across the bigger side here. So in this case, this would be triangle EFD, right? We went across this blank side and then across the bigger side, and we ended at the angle that was congruent to each other. And this would be if we wanted to say SAS similarity. Then over here, we are asking, so KJH went across the middle side and then across the smallest side. So and that's similar to triangle across the middle, across the smallest side. So that would be NML, triangle NML. And this would be by side, side, side similarity. So on this back side, just like on the front, I'm going to read through all of these relatively quickly, and if you want to pause the video to write them down, go for it. So an altitude is the line segment from a vertex that is perpendicular to the opposite side. An angle bisector is a line segment that divides an angle exactly in half. A line segment, these LS from here on down are mean line segment. So a perpendicular bisector is a line segment from a vertex that is perpendicular to the opposite side and bisects it. And a median is a line segment from a vertex that bisects the opposite side. So that means, again, cuts it perfectly in half with bisect, right? A LS, so for mid-segment, it's a line segment that connects the midpoints of two sides. Area is just the amount of space in a two-dimensional figure, and volume is the amount of space in a three-dimensional figure. So we got 54x equals 9,720, which if we divide both sides by 54, we get x equals 180. And we're going to come in and we are going to do number 4 together in class. See you then. So what we need to do for these 4 examples is we need to set up a proportion of the smaller side here with the smaller side here and the bigger side here with the bigger side here. So our proportion here would be x over 21 equals 11 over 33. We want one triangle to be on top and the other triangle to be on the bottom. So in this case, we would now cross multiply and find our cross product. So we would say 33x equals 11 times 21, which is 231. So with this, then we would divide both sides by 33, We end up with x equals 7. So in our next problem, we're going to set it up very similarly to what we just did. Again, some of these are more rotated than others, but they're still pretty straightforward here. So in this case, x goes with this larger side over here. X goes with the 24, and 8 goes with the 12. So when we cross multiply, we get 12x equals 192. We divide both sides by 12. We would get x equals 16. So, and then for this next one, example 3, we can say that x over 72 equals 135 over 54. We do not always have to have the larger numbers on the bottom. The larger numbers can be on top. It's just as long as we have the same triangle on the top and the other triangle on the bottom, we're fine. So in this case, we are cross multiplying here again. We would have 54x equals, I'm going to need to multiply that out.